This video is just to get you started on doing number 9 from the second homework set. This is Tipler chapter 2, problem number 57. You have a submarine that is sending out pings, and they bounce off a cliff and then come back to the submarine. You have a time between when the pings are being sent out. In the example shown here, your number might be a little bit different, but mine on this one is 4.2 seconds. They bounce off the cliff, and then the submarine detects them at every 4.18 seconds. So a little bit shorter time than what they sent them out at. So here's the situation and why it works out that way. Is you have, say, the submarine here, and it's sending out these pings. They bounce off of a cliff over here and start coming back. So picture these as waves, sound waves, traveling back to the submarine. They're going to be equally spaced. We know the speed that those waves are traveling. That's at 1522 meters per second. So we know the actual distance between those waves. Since it's a constant speed, you can just use the displacement or distance between the waves. The sound waves is going to be v bar times t. Now let's call that t1. That would be the actual time between the pings. In this case, 4.20 seconds. Okay, and if the submarine was stationary, just floating in position, it would hear the returning pings every 4.20 seconds, because that wave would hit it, and then the next wave would come, and then it would hit the sub, and so you'd have a time between those waves of 4.20 seconds. But the submarine is moving. So if the submarine is moving towards the cliff in this direction, call that V of the sub, it's going to encounter the next wave earlier than it would if it was stationary. That's why the time is less than the time that they sent the pings out. The emission ping, how long it is between those, is greater than the return reception pings. If we look at what's happening, here comes, let's just take this wave right here and let's blow that up a little bit. So you've got these two waves. Let's say here's where the one wave would hit the sub, but then it's moving forward. So in a certain amount of time, it travels a certain distance. So there's the sub traveling. So it goes a certain distance, but in the same time, this wave has traveled to this point and has met the sub. Okay, but originally we had that distance of delta x equals v bar times t1. The total distance here is equal to that v of the speed of sound times the emission ping time, but then also you have that same distance is equal to the distance traveled forward by the sub, that would be this distance, plus the distance traveled by the wave in that shorter reception ping time. So if you take these two distances and add them together, they should be equal to your original distance, the actual distance between the waves. I hope this helps you get started on solving that. I'll let you do the rest from there.